Today's lesson is on U1L6, the slope triangles, and the objective is going to be determining the slope of lines by using slope triangles. So recall from last time when you have a table of values, you can find the constant rate of change by finding the change in the output and the change in the input. So I see my output, the change is 3, my input, the change is 1. And you also can do that to these 2 points down here. The change is now 6 and 2. So the constant rate of change is the change in the output, which is 3 over 1. Output over input, so 3 over 1, or 6 over 2. And you notice that the values are equal to each other. That means that it's constant, right? Between any 2 points, your rate is the same. 6 over 2 is equal to 3 over 1. That's a constant rate of change. Now imagine if you put that on a graph, okay? You expect this to be a straight line, of course, because the rate of change is constant, just like how our sequence is arithmetic. It's a straight line. Now I'm going to plot my points on here. Here's my 1, 4. Here's my 2, 7. And here is my 4, 13. Okay? Now, between these 2 points here, I can make something called a slope triangle. Okay, so I imagine I move from one point to the next, but I can't go straight to it. I got to go only along the not diagonally, but along the horizontal and vertical lines. So go straight, sideways, or up and down only. So I got to go sideways this way, and I got to go up. Now you guys notice that this is a triangle, and this is what's going to help us to find the slope. Okay. When I create this triangle, I can count how long the sides are. Okay, so going upwards is my rise because I'm going upward, right? And going sideways is my run. And then I count how long the sides are. The rise is 3 squares, so that's positive 3. Remember, I'm going upward, so it's positive. If I were going downward, it would be negative 3. But I'm going up, so it's positive 3. And my run is 1 square going to the right. Going to the right is positive. If I were going to the left, it would be negative. Now the slope is just these values here, okay? The run is 1 square, by the way. So the slope is the rise over the run, which is 3 over 1, okay? Now if I were to use these 2 points and make that triangle, I still have the rise and the run, and I count them. The rise is going upward 6, so it's positive 6, and the run is going to the right 2, so it's positive 2, which gives me the value of 6 over 2. You notice how the slope, the values, are the same as in the constant rate of change. So essentially, the slope and the constant rate of change give you the same value, 3 over 1. But in a line, you use the word slope, and in your values, you use constant rate of change. Okay? Let's do an example here. I have a straight line, so I can find that slope. Remember, if it's a straight line, then there is a constant rate of change, meaning there is a slope to find. Now, which points do I pick? Do I want to pick a point in the middle here somewhere, so it's decimal? Or do I want to pick a point where it's whole numbers? So I would pick a point where it's at the corner where there are whole numbers only, right? Right here, I have whole numbers. That point is 1 and 2. And I pick this point up here. It's 7, 6. See, whole numbers better than decimal. I can count them. So I make my triangle, rise and run. I count. Rise is going up 4, so it's positive 4. The run is going to the right 6, so it's positive 6. So my slope is rise over run, which is 4 over 6. And remember, you always have to simplify it, so it would be 2 over 3, right? Now you imagine if you were doing this by yourself and you pick a different point, would that change my answer? Right? Think about this point here. This is also a good point to pick because it's right at the corner, whole numbers. So that's 4, 4. And, I can also go backwards to see what happens, right? So instead of going from the bottom up and left to right, I'm going to go backwards. So here I go toward the left and I go downwards, okay? So going toward the left, my run is now negative 3, right? Negative 3, because I'm going to the left, and the rise is going down, so it's negative 2. So my values come out to be rise over run is negative 2 over negative 3. which I can simplify into positive 2 over positive 3. Remember, negative divided by negative is positive. So the negatives cancel each other. So the point is that you can go from any point to any other point. You don't have to go from left to right. You can go from right to left, and that'll make you go down. Okay, so here is another another example here. I have this line, and I want to pick 2 points. This one is 2, 7, and this point is 6, 1. Okay, there's my triangle, my up and down, my rise and run. Okay, my rise is going to go down, so it's negative 6. My run is going to the right, so it's positive 4. So my slope is rise over run, negative 6 over 4, and I can simplify that into negative 3 over 2. If I pick this point here, 4, 4, and I go backwards, like this one, see, I go up and toward the left, I make that triangle. My run is now negative because I'm going to the left, and negative 2, and my rise is going upward, so it's positive 3. So I get 3 over negative 2, which is the same. If you have one negative sign either on top or bottom, it makes the whole value negative. So these two are equivalent.